Okay, well, welcome everybody. Appreciate your time and thanks for attending today's webinar on mastering O&P design workflows. And my name is Kevin Atkins. I'm the product manager for Octon Freeform. And I'm very happy today to be joined in this webinar by Brent Wright and Katie Richmond of Advanced 3D. We'll get into introductions in a second. I'm first going to go through a couple of slides of what we're doing, and then we'll get into the real meat of the presentation. Questions? Please feel free to post questions in the little dialog box there. If we can answer questions as we go along, then great, we certainly will. Otherwise, we have a Q&A session at the end, and then we'll come back to answer the questions at the end. Alrighty. Just got to have one little thing here, or two little things, the agenda. So first, we've got the introduction I'm doing now. Then we're going to go through Brent's journey to the digital workflows. And then we'll go into some demos. So first, Brent will demo a wrist hand orthosis. And then Katie will get into scripting for a transtibial prosthesis. Then I'll do a quick little demonstration of some of the new tools that are coming in Freeform version 2025, and then we'll have the Q&A and close. One last thing I need to do is just talk about the regulatory aspect of this. Our regulatory team are pretty tight, so we have to go through these things. So I'm just going to read this, and then we can get on with the rest of the presentation. So Freeform is not a medical device, and Octon does not claim that it is intended for medical treatment, planning, or diagnosis. While many customers have successfully integrated Freeform into their workflows, it is essential for customers to comply with all applicable regulatory requirements. The examples provided here serve to showcase the application of Freeform in the healthcare sector. Okay. And if there's any questions about... You have to read all that,
don't you, Kevin?
I sure do. Yeah, I've got to keep my regulatory team happy. I like them very much.
Yes.
And if you have any questions about, okay, well, you're saying Freeform's not a medical device, so how do I get it working within my framework? Then please feel free to reach out. We can certainly discuss those and answer those questions. All righty. So I'm going to stop sharing my screen for a second, and we will... Got to find the stop sharing screen button. That should be stopped, I hope.
Yep, it is.
Grand. And I'm going to introduce Brent Wright. So Brent, if you can introduce yourself and do all that, well, we'll get going.
Yeah, my name's Brent Wright, and I'm super excited to be here with Katie, who has taken the Freeform really well too, and so we'll hear from her shortly. But I'm a certified prosthetist and orthotist, and have really taken a liking to design and digital workflow for orthotic and prosthetics services or design. I think one of the things that it's important to note is I was a clinician that was anti-digital. So I truly believe that it was only what my hands could do, what I could do in plaster, Sureform, and boy, was I wrong. So I really thought that people that use digital tools just actually didn't know how to practice. I mean, I know that sounds rough, but in my mind, that's what I thought. And so I think it's important for people to know that perspective, and really how I've done a 180-degree turn into believing that, hey, if you're not thinking digital first, then you're potentially shorting your patients from an outcome that they deserve.
So Brent, why did you start on the digital journey? If you were happy doing things the old way, let's say, what made you change?
Yeah, so I think it was, well, I do a lot of work in the developing world, and I'm going to throw a slide up here shortly, but it really started back in about 2014. We had taken a team of 3 clinicians, no other technicians, and we had a clinic that we did, and we were jam-packed. So we did 63 devices, most of them transfemoral devices, over the course of 6 days from start to finish. So evaluation, casting, all the modifications, and all the manufacturing. And as people are probably listening to that, their eyes are twitching because they know how much work it is to make those sockets. And I came back and I was so tired, and I actually had a colleague of mine say, "Hey, Brent, I think what you've done and is really cool, but like, okay, so you help 63 people, but how many amputees are there worldwide or in Guatemala?" And so when I did a little bit of research, it was like 100,000 people needed some sort of prosthesis just in Guatemala. And he goes, "So what about the other 99,000 and some, people that need it?" And it was at that moment that was the turning point for me. Is it's very hard to scale doing it the traditional way, but with distributed manufacturing, additive manufacturing, digital manufacturing, there's a chance that we can start to reach the 30+ million people all over the world that don't have access to care right now.
So you're packing up all your physical tools, jumping on a plane and going down to Guatemala?
That's right. That's right. And I just want to share my screen here. So
what about plaster? I mean, talk about overage
Yeah.
fees on an airplane.
Well, yeah, so you've got the plaster, but what's crazy is that a lot of places in the developing world have molding plaster. So they're doing ornaments and trinkets and that sort of thing. And some use it for some construction and decorative stuff. So getting plaster wasn't too crazy. Are you able to see this screen, Kevin?
Yep,
Of Veronica?
sure can.
Okay, so this is really where it all started. So, most people, or a lot of people, have heard this story, but it's still a story worth sharing. So Veronica came to us 2017, 2018. It was really right when I started 3D printing stuff, and she had lost her arm protecting herself. Masked men came into their house. And she was protecting herself to get away. They actually took the life of her father. And when she came to us, she was depressed and really didn't have any hope. And so, and upper extremity wasn't typically what I did. And so I said, "Yes, we're going to help you. We're going to 3D print you an arm." Now, I had never 3D printed an arm, before. And so we did that. We had some color plastic, like a light tan plastic, and we 3D printed an arm. And even though it was a passive arm, when we put that on, it was like we had Veronica back. And the smile came back. And then she started working with our organization, Life Enabled, consistently. And so she's there now every time. But what's interesting is through that journey, as we started to get to know her more, she's like, "I'm missing an arm. I'm never going to get married. Nobody's going to love me because I'm missing my arm." Well, I'm so happy to say that Veronica did get married, and she now lives
Sorry.
and now she lives a full life. And I just love that story about her and really what additive manufacturing can do in the life of one person. And I think that's important to note, is that prosthetics and orthotics is different because every single one is different. Everything presents differently. And so you need the tools to follow. And I know we'll get involved, but needless to say, Veronica's very happy. We've met her husband. Her husband's involved in the clinic, and it's great. But this is my why. This is why we have gotten involved with additive manufacturing and now bring it back to practice in the US.
That's such a great story. So seeing that, how do you capture how did you get the impression?
So the neat thing is that digital tools don't necessarily mean that you have to move away from traditional styles of capture. So for her specifically, we actually captured her arm with a cast, and then we scanned the cast and then made the prosthesis from that. So we avoided the plaster route, but we still used the physical form of a cast. And what I will say is there's definitely different opinions on which way you go, but I can say people are successful with direct scanning, so scanning no cast. People are successful with taking a cast, scanning that. People are successful with taking a cast, pouring it down, and scanning that. So I think what the biggest takeaway from all this is that you can be successful if you lean into the tools and use them in the way that you know how.
So before you found Freeform, what were you using? How did you go from, what were your steps along the way from the old style physical to where you are today?
Yeah, so when I first got started, I found out about a software called Mesh Mixer, and this was before Autodesk acquired them. And then I used Fusion 360. So there were multiple steps. So you had to go Mesh Mixer, and then you had to find a software to go to quads, and then take the quads, go into Fusion 360. And it actually worked pretty well. But here's what happened is I was in Guatemala in 2018, and there was a hurricane that actually came across the Guatemala area. So the eye of the hurricane actually came right across where we were at.
Wow.
And so we're in the jungle of Guatemala, and luckily we had battery backup. So I was going to have the 3D printers rolling. We had diesel and all that stuff. But one thing we didn't have was an internet connection. And so when I pulled up Mesh Mixer, I'm working stuff, and then I go to use my Fusion 360 workflow, and I had no internet, and Fusion pings the internet because, most people all over the world have internet, and I could not get on. So I was stuck. And it just so happened a week before I left for Guatemala, somebody from Freeform said, "Hey, Brent, you should try Freeform." And I said, yeah, whatever, send me a demo. I may get to it. And then I realized I needed it, and I didn't need to ping the internet. And so I literally used Freeform to create some of the devices that I needed to while I was there, because I didn't have internet access. So the reality is, Kevin, you and I, because of just how stubborn we are as prosthetists, we probably would not be talking today if it wasn't for a hurricane. That's the reality of it, is I would still be in the same flow that I was in, but I was forced to use a different tool, one that I was not familiar with. And then I found out that there was something better in the workflow that made me more efficient.
The proverbial silver lining in the cloud, big cloud in your case.
Yes. Yeah.
So it sounds like you only had it like a week or two before. So how did you just start using it so quickly without training courses and?
Well, so I think that's the other neat thing is that both Katie and I were technicians before we got into the field. And so we had an idea of how to make things, like what are the actual processes. And so once you head into a digital workflow, you also have a basic understanding of what you need to do. Now, I didn't know what these tools are, which is why, when we're talking, Kevin, sometimes we're talking the Blue River tool, the Green River tool, the Lego tool, the Hot Lava tool. Those are all the things that we talk about. And that's not the official name of these tools, but that's how we
whatever works.
But nonetheless, there are a lot of tools that do transfer from place to place. And if you I was definitely into Mesh Mixer and Fusion 360, and I knew what I needed to do. And so I was literally able to fumble around and get some of the things that we needed to do just by trying it. And yes, it took a longer time, but I didn't have internet, so I wasn't even able to YouTube stuff, even though there's not much YouTube stuff on how to make stuff, especially back in 2018. So it was just really trial by hurricane that we did it.
Cool. Well, as long as we're helping the patients, that's the main thing, right?
That's right. That's right.
So we keep an eye on time. We want to make sure we get everything we need to get done through the time. So I think we're at the time where we want to start getting Brent to show us how he actually uses Freeform. So Brent, if you want to
Yep.
share your screen, can I make you presenter, or?
Did it come back up?
We're learning. Yep, there you go.
Okay. Okay. So, and the idea of this is not necessarily the final product of what a WHFO is, but really it's about paying attention to the tools and how those tools transfer and build on each other. So a wrist hand orthosis is essentially one of the most basic devices that you can make. And so I'm going to take you through the manual way to do it. We're going to talk through it. It's going to take a few minutes. But the neat thing is, and then I want to reiterate, this is the manual. So some people are going to be watching this and say, oh my goodness, that's, look at all the steps and all that. Well, when we get to the next part where some of the automation and such can take place, I hope that you'll be able to see the building blocks. And I think the biggest thing for me is with Freeform, I never am going to get stuck for an output. I can always make something work. And also Freeform has a great mesh editing tool. So I can be in there from the very beginning all the way to my export. And I think that's what's important. And so what I'm going to do is just quickly go through some of these steps. You're going to probably have to rewind the webinar and even slow some of the things down just to see what we're talking about. But the neat thing also about Freeform is, so we've got a scan that has come in. I just for the sake of speed, I went ahead and aligned it to the origin, and it is fairly cleaned up. But what I didn't do is, you can see that there's lumps and bumps that we're going to want to get rid of. We don't want to print those lumps and bumps in. They don't belong to the patient. It's just artifacts of the scanning process itself. Not a typically great scan, but this is absolutely fine, and it's an easy scan to work with. So what we do, once we have a mesh, we move out of the mesh and into what is called voxel modeling. And so voxels, think of it as a piece of sand. And I am using sand, if you look down in the bottom left-hand corner, that is essentially a 1.5 millimeter by 1.5 millimeter by 1.5. So fairly coarse sand. But you can see that that already took some of that triangulation away, and we've got something smooth. So from here, Katie has...
By the way,
go
Brent,
ahead.
sorry, are you using the haptic device at the moment?
I am, yep. So the haptic device is very awesome. So I call it my digital Sureform. And so I can literally feel the model underneath my hand. So I have full access of rotation, but then I also get haptic feedback on when I push on the model itself. So great call. And we may have to just do a separate thing about the haptic device because it is such a powerful tool. And for those of you that do TLSOs and hip disarticulations, large transfemorals, and you know the pain that of turning 70-pound plaster models, and then when you see the haptic device where you can, with the flick of your wrist, literally turn that around, that is the beauty of this kind of digital workflow. And it's not a mouse, so it is very intuitive way to control your model in space. So we've got this clay model, and I'm just kind of looking around seeing what I need to do. I have labeled it because Katie has taught me to label things, because now that we work together more and more, it's important to know what each other have done. So we try to keep this tree as clean as possible. So what I'm going to do is I'm actually just going to smooth this a couple times. And you can kind of see that we've smoothed it, and we've started to take some of the lumps and bumps out, but we've got some shininess, and that's what we want. And then I'll bring this original mesh, and you can see Freeform does just an amazing job cleaning up the model without losing or decreasing the circumferences. So I always do that as a check. But we still have some lumps and bumps, and we're going to kind of cruise through this. We're just going to clean. So this is the hot lava tool. What is the official name, Kevin? The smooth tool?
It's right down there in the bottom left, hot wax.
Hot wax. So we're close, hot lava, hot wax. So we've cleaned that up. And then we know that we want to have some sort of relief. And typically we do a relief over the styloid process here. So we're going to bring in this tool. And I love it. Gregory George is actually the one that taught me this one. And it's called the Haze tool. And so it's a gradient map. So you can kind of see the gradients there. And it allows you to place or mark an area using that gradient on the styloid process. And then we're going to increase it in size. And the beauty is, so I just increased it 3 millimeters. And to show you that I did do that, we have a build up there. And so we increased it 3 millimeters, but there's no smoothing that's going to need to be done there. It's all nice and smooth already. So now what we're going to do is we're going to put some trim lines on this. So I'm going to put the thumb trim line on. And you always have to click this little box, fit to clay on create. So now I'm literally pushing, it's like using an indelible pencil. I'm pushing onto the model, making this arc. Okay. And the cool thing is I can actually I can whip around this just by feel a lot of times. Like I don't necessarily have to see those marks because I can feel it on the back of the mold. And then just in the interest of time, we're going to quickly do this. And the people that make, WHFOs for a living, just know that this is may or may not be clinically relevant. But the idea is just to show you what is possible. So we're going to come here. We're just placing this. We're going to also relieve for that styloid process here. So I'm going to finish up these trim lines. And we've got some trim lines. So these aren't perfect, and you can go back and change them if you want to get some of the wobblies out. And the less dots you have, the better off you're going to be, and you won't have these kind of wobbly looking dots there. So let's just call that good. And so what I do from here, and Kevin, you may not love this, but this is what I've found works for me. And I just wanted to use this opportunity to also challenge other software manufacturers to allow clinicians to get to this point right here. So I have gone back into the mesh tools, and I am going to select the brace that I want. Now I have everything in the trim lines that I want. And so this is what's important for other software manufacturers to watch too. If you let me get to this point in your software and export this file with trim lines, I may actually use your software on the front end to do this. And then I can use the automation on the backside. The problem is most softwares will funnel you all the way to the definitive product and don't give you options. Well, right now I have a ton of options with this into automation. So from here, we're actually going to put it back into clay. Depending on what my last setting was there. And I'm going to actually put it at, so we're going to go double the clay coarseness, and we're also going to just thicken this. So, and we're going to thicken it to the outside, and we're going to go 2.5 millimeters, which is the typical wall thickness for powder bed fusion. So not really super amazing looking, like the edges look a little bit raggedy and that sort of thing. I don't care right now. I'm just trying to get something quick, and then you'll see to use the magic. So I'm just going to say, hey, I want some air holes in this area. So I got to actually push on the top there. And right now, I'm going to use this tool here, and I know that my thickness is 2.5 millimeters, so I need to go further than 2.5 millimeters, which so I've got I'm going to deboss 4 millimeters and cut all the way through, and I press apply. Okay, so still not amazing looking, okay? And some of you may be twitching and such and be like, what are you doing and showing me this? However, I'm where I want to be, and now this is one of the beauties of playing in the clay coarseness is I can say, hey, I just want to bump up the resolution of this just a little bit. And now I've smoothed everything out. Literally, I've doubled the resolution, smoothed everything out, everything. So edges here, and I'm ready to rock and roll. And so, you know, this is not the most beautiful wrist hand orthosis, but this gives you an idea of what is possible. And, you know, it took me, yes, maybe 7-8 minutes to do and talking all the way through it and talking about the haptic device, but we're in something that's printable very quickly, the way that I want it, which is what I love. So that's
And then that's in clay, but how would you then get it out to a printable format?
Yeah. So from there, you have two options. You can go straight to export, which a lot of people do. And you can do it. You end up with some larger files depending on your clay coarseness. So what we've started doing as just kind of a best practice is we've taken that clay and put it back into a mesh. And I will say, like on the export side of things, you can export into a 3MF, STL, PLY, and there's a bunch of other ones, OBJ, 3MF being a much smaller file, and you guys are part of the 3MF consortium too, I might add. So if Duan is watching, thank you for running that. So now we've got this clay here, but now we can go mesh utilities, reduce, and Freeform is great at reducing meshes and making those file sizes smaller. So depending on, so right now we were at like 1 million triangles. And so now I'm saying, I know that about 250 triangles, 250,000 triangles is about 11 to 12 megabytes, which is a very manageable file. And if you're really any bigger than that, your powder bed fusion printers probably will not pick up the detail unless it's something that's super crazy latticed. So that's the way that I would do it. So once you have that, cool, you can actually export it out however you want. So I'll show this, and I'm not sure exactly where that's going to go. Oh, so good. That's good. And you can see we're at 11 meg file right here. So yeah, you're off to the races. You've got a printable file that looks, you know, beautiful, organic, professional edges with not a lot of work. So.
And you're happy just jumping between the different formats, voxels to mesh to whatever else you need, curves?
Yeah, so I think that is one of the beauties is one of the things that's interesting when you're moving between different pieces, and you have to know which ones you move between, but like you can go through and thicken on the clay and all that, but you've got quite a few more steps, which I might add you would want to automate. But this was a very fast way for me to get to where I need to go. And the other thing that is to be noted is that you want to do all your modifications and get your final device before you go into mesh and add things like chafes or belt loops or what have you, because then you can keep the resolution of those devices when you Boolean them together.
Cool. So speaking about automation, it's time to introduce Katie. So I will make Katie a presenter, and then Katie, if you can introduce yourself. Oh, don't think we can hear you yet.
Sorry.
There we go.
Can you guys see my screen?
Yes.
Okay. I'm Katie. I have been working with Brent since February. Prior to that, I was using Mesh Mixer and Fusion 360, and all the same things Brent said, that it's not that you can't do it, it's at what cost to your time can you do it. So it's been really fun working in Freeform. It's a lot more intuitive and it likes organic shapes versus the nightmare of just getting an error message in Fusion. But what I'm going to show today is, as Kevin called it, a scripted path. And I will be showing you a Dinobot, which I built, that's going to take me step by step through everything you need to do to turn an already modified scan. So an example, we were at our national meeting, and Radii is one of the companies coming out that they'll actually help with modifications, but this is a modified socket, but it's a mesh. It's not a physical thing that you can hit print on. So this is taking you from a mesh that has been modified, which you can always do in Freeform as well, but it's going to take us through how to do that. So I need my haptic device up.
Cool.
In case anybody hasn't seen what it is. So we'll just click begin and we'll read through this. I'll talk a little bit about what's going on in the background. So I have already told it what files to load and what they should look like. I'm just gonna write demoing. It's prompting me to save it. And then ready to import your scan, letting you know that both STLs and OBJs are acceptable. Coming in here, grabbing that.
It's a smart move to save at the beginning.
Don't I know it? Yeah, from experience. So again, kind of just following through, clicking continue, next step, aligning the scan. And Brent and I, as again, another little best practice just for uniformity, we keep F2 is always the posterior. So Freeform would call it the front view, but we always find it easy to have a straightforward view. So I'm just moving these around. What is happening behind the scenes is I already told it that I want none of these options turned on down here, which if you're not a Freeform person yet, we can go into later or ask questions. But essentially I set it up because I knew that's how I want it to be, and you need to get the lock on the bottom, reference these, continue. So
And it's cool you can see that your haptic arm there because you're doing full 6 degrees of freedom.
yeah,
All in one. And now you're off and it's just running through the script.
yes. So all of those things were happening with me, my hands up here doing nothing. And it turned our mesh into clay. It renamed it so you know what it is. And now it's saying, hey, make sure before we move on, even though this is a modified shape, make sure there's not any funky bumps or anything that you don't want, which I chose it because it's already good, but you can smooth it up if you need to. So you're like, okay, cool. Now I like it. Okay, use your pencil tool, which is already selected. You didn't have to select it because I already programmed it to do that. I already also told it that it should be fit to clay. And again, if you see my haptic device, it stops because it's giving resistance because I'm touching the model. So I'm just gonna click around here. throwing these trim lines on.
And if anyone is seeing like a jaggy screen, that's just the internet speed. At your end, you're seeing this completely smooth and everything is just running nicely.
Oh, yeah, it is.
Yep.
Okay, so I finished it up.
Where I live, we have a really bad internet speed, so I just wanted to make sure.
And hey, you made that line, but let's double check and make sure. And you're like, you know what? That hamstring doesn't quite look right. So I want to pull that down a little bit. And this down. Okay, that looks better. So what's our next step? Just click continue. So again, that did some automated stuff, and it created a plane, and it's asking you to grab onto the plane and drag it down to where you want to create a loft between the top of the lock and the bottom of your model, which in prosthetist talk is when you have finished modifying your shape, you flip your cast upside down, you pin your lock mold on top, and you're like trying to fill in that space with plaster. That's what we're trying to do with this. Okay, so I'll grab this, and doesn't need to be very big, just a little bit. Okay, now to get that loft, notice it says click on both the purple lines. So here and here, they'll turn green, and that'll give us our loft. Awesome. Now there's a little bit of a ridge, not much, but I can smooth that up a touch. Okay.
So all you did was position the plane, and then the script automatically took over and did the intersection between the plane and the model to give you that curve to blend it to.
Yep. And showed up a different curve from a solid bot. Yes, all of that was on the back end. And then it's just saying click to place the little green seed where the socket should be, which will be there. And I have this automatically set up to create a 4mm thick check socket because that's pretty standard for us for transtibial. So again, it went ahead and thickened it. It also created a new body over here, and it's saying, okay, now same thing, grab the plane and drag it down to where you want it to loft externally. So instead of the check socket coming down like this and having a severe sharp transition to the lock body, we're going to give the outside a nice loft, which one, looks nice, and two, adds strength. So.
Quick question. Whenever you've done those offsets, whether you go inwards or outwards, have you ever seen one that's failed?
Not on that, no.
There's a leading question for the CAD guys out there who are used to using B-reps and crazy models, organic models like this when they do shelling. They'll know what I'm talking about.
Okay, again, turned on some different curves and is prompting me to select these two. And it's pretty nice, but we always want, well, I always want perfection. So let's just smooth it up a touch, soften that transition. Pretty good. Okay, so this is the fun one that's a little harder to see, but it's just saying, hey, which side do you want the lock to face? Now on this one, being a right and preferring medial, it's already in the correct direction that I would choose. However, say you used a different, this is a left. So I'm gonna say, okay, even though I'm visually seeing on my screen the right facing one, I want the left facing option. So I click on that, and again, I'm not doing anything. And it's changing clay coarseness, it's smoothing, it's doing all of these things on the back end, turning it back into a mesh. Now it's really thinking. Okay, now it is prompting you to add a PO number. So PO 123. Okay. And it says, yeah, obviously. Click on it where you want to engrave it. So I'm just pressing on the bottom and it turned red, which means that little seed is in the correct place. And I click continue. And there we go. So
Cool.
this is finished and ready to export and print. And that is just a lock body to visualize, but it's not in there.
And then you're relatively new to writing Dynabots and scripting inside Freeform. How long did this take you?
Well, the down and dirty was pretty fast. I would say if you're doing something and you want to turn it into Dynabot, I'd say you probably got to do it about 3 times through. So, but then that
Just
was
learn the
to get
workflow.
all of these in place. And each one of these is just a heading to all of the keystrokes and things that I wanted it to do.
Cool. But you don't have a programming background or a scripting background?
No, I don't at all.
Grand.
Am I throwing this back to you?
Yeah. So
Yeah,
I mean, I think that's awesome, and I think it's amazing. Like so literally somebody that is new can then pull that in and they can follow the step-by-step directions. So I think one of the things that has been important to Katie and myself, and it's really kind of changed my mindset, is 100% I want people that are craftsmen, artists, best at their job, that sort of thing. But I also want something that's repeatable, that I can hand off to somebody on the non-essential parts, that they will follow a script. And we're talking about scaling, and the best way to scale is to create recipes. And we're not saying turn off your prosthetist or orthotist hat. We're saying, hey, we want you to make all the clinical decisions in the world that you want. And we're here to help you design the device on the back end that you intended. And so I think that's where I really go with the automation. And one of the things that we haven't talked about is measurements. So, most free or reduced cost software will not take perimeter measurements. Or somebody will tell you, hey, oh yes, I can take a perimeter measurement. And then they show you the math gymnastics that they have to go through to get one perimeter measurement. That's not really a great way to go when you've got a live device that you're trying to get 2 measurements. So you've got linear, volume, circumferential or perimeter measurements, all these things, and some of that can be automated. And I think those are some of the new tools that are coming to the product, which I'm super excited about. But so for me, and Katie mentioned radii, and I think this is important for people to know, is they are doing automation on the front end to capture stuff and are very successful. Now, their sockets may not look like our sockets, but this is the crazy part. Their development is rooted in science. And so they're training these modules based on the result from prosthetists, based on the results and patient comfort scores and all that stuff. And so they get close every single time, regardless, but that's where it stops for them. They are really good at that part. We want to be really good at creating the devices on out, and we want to encourage people to measure what they do. And I think that's where Freeform really can come into play, is you can truly measure what you do.
Yeah, that's an important point. Can you guys see my screen, by the way?
Yes.
Okay, great. Because Freeform started as like a figurative tool, but we always gave a lot of respect to the engineering. You know, whenever you actually want to make something for real in real life, real numbers become super important. 3 millimeter thickness, 2 millimeter boss, all those sorts of things that are super important. So it's not just about sculpting something or making something look pretty. It's also about the engineering that goes behind it. So that's something that's also been there from day one with Freeform. And then thanks for showing us that, by the way, Katie. And we'll jump into this last demo and then we'll get into the Q&A. So this last bit is just showing you some of the new tools that are going to be coming in Freeform, the next version, which is about to enter beta. And then we're aiming for a release end of the year, beginning of the next year. And this is one of the new tools, like Brent was saying, measuring perimeters. So I could just put my tools anywhere and measure these perimeters. And then as you go back and modify the model, you can hit update and you can see the perimeters update. So you're getting those real measurements. But if I go back to my solid liner here, and I'm only showing you a couple of the new tools that are coming. There's a whole bunch of things coming along the way. One of them is Voronoi patterns. One of the things we've worked with a lot of customers with is they still go to external software to do things that Freeform today can't do. So we've been analyzing those, and one of the requests we heard was we want a Voronoi pattern. So we came in, and with this guy, what I can do is now select this loop, and there's a couple of options down here, but I'll just accept a curve length and I'll hit preview. And you'll see it's going to come into that selected loop of curves, and it creates my Voronoi pattern. If I want to change this, right now it's relatively consistent. But if you want to have a smaller spacing at one end, what I can do is come in here, I can add a point, a density zone, and then hit preview again. And you see now we've got these density zones coming in, and I can come and change these. I can change the radius, the scale, etc. And then the other thing I can do here as well is if you have a liner underneath a lattice, sometimes you want the holes in the liner for ventilation to line up with the lattice. So what I can do is grab these center points, and now I've got center points which I can use later on to put in the holes for the liner and then have the more rigid brace on top. And I'll turn off the center points and I'll turn off the density zones, preview that again, and then apply that. Oops, it helps if you hit the button. And there are the curves that come up, nicely organized in a subfolder here. And then I can go to just something like, what have we got in detail clay? Ridge, for example, and I can grab all those lattice curves, just select the lot, and then select the boundaries as well. And then I can just add a ridge quickly. And then with dynamic control, you can always change the size of these in real time, or you can type in the numbers. You know, the numbers are super important. Again, bring up the settings. And then you can easily just accept that in. Ooh, let's hide the settings box. So there we have a Voronoi net. So that's one of the new tools that's coming. I'll hide that quickly. Go back to the solid liner, bring the curves back. And then I talked briefly about adding in holes for like perforations, make it more comfortable to wear. And that's where another new tool comes in. So I go down to my perforate tool. And I don't have to select the curves, by the way. I can just randomly select areas, but I'm going to use this curve tool. And then we're going to do divot mode. We're going to do equal triangulation. I can see, got more profile settings here. So we're going to do size. Let's hit preview and see what happens. And you see that's a relatively random distribution we have there. If I change that to UV projection and preview again, so now we have a much more aligned projection. And if this came in skewed, for example, I can start changing the angle. Or I can change the distribution. So I could go, instead of a regular pattern, I can have an hexagonal pattern. And then when you're happy, you can go all the way through. So I'll just put, say, 5 millimeters for now. And let's apply that and see how it looks. So a relatively simple tool for adding like perforations. And then when you put all that together, if I hide that, and then I'll hide these curves away. So then we have a liner. And these holes may look fairly random at the moment, but these are the points that I used to align with a bracket here. And then on the bottom half, we can just finish it off. So those are some of the new tools that are coming in Freeform along the way. Like I say, they'll be out towards the end of the year, beginning of next year. Just turn on the paint color so you can see what's going on there.
I love that. That's great. And that's going to be super useful. Wow. For
so
and clinically relevant. Like I think that's the biggest thing, is that you guys are putting in features, obviously, that people request, but that are definitely clinically relevant, that are going to help outcomes. And I think this is going to be a really good additional feature to it. So I'm looking forward to getting my hands on this one.
Cool. Yeah. Well, you're one of the people who helped us point us in the right direction to add these tools. So, we're very thankful to you and all our customers. Alrighty. So that's the end of the demonstration of the new tools and the demonstrations of the workflows. So now we're going to go into the Q&A phase. I will bring this back up, bring this up, hit F5 and swap because it's always on the wrong screen. Okay, so just take a quick look at time. We're about 8 minutes to go before the hour is up, and we've got a bunch of questions that have come in. When I'm looking to the side, by the way, I've got the two screens and I'm looking at all the questions that have come in. Ooh. Alrighty. Sorry, we're still getting used to GoToWebinar, so these little things. So one question here.
Yeah, go ahead.
Oh, sorry, go ahead.
I was just going to read. So I saw this question for Brent when he was smoothing the entire handpiece. So it says, when he was smoothing the entire handpiece to remove lumps and bumps, some of the finger features also lose material during the smoothing process. How to secure some critical features, fingers in this case, while performing any smoothing operations. So this is where you use your clinical judgment. So I kind of knew that this question was going to come to somebody that knows what they're doing. So I have a feeling I know who the actual questioner is, but nonetheless, this is where you make a clinical decision. So you might apply a smooth and say the fingers almost go away. Well, the fingers are way out of the trim lines of the brace that I'm making. So I don't really care that they go away. I just care about the rest of the model. However, when you are wanting to keep some of those critical features, you might have to go to more of a manual mode or create a mask. So, and this is where you can really dive in the deep end, but there is something called a buck, which means that you keep the mesh, or not the mesh, but the voxel, everything and anything that you do as an addition to the buck itself. So what I would probably do in this case is smooth where I wanted smooth, change it to a buck. I wouldn't do a global smooth yet. And then once it's in a buck, I would do a global smooth, which means that the fingers would not disappear on me. So But this is a great observation to whoever observed that, but that's what I would do. And I don't know, Kevin, maybe I'm missing something. Maybe that's not the appropriate way to use a buck, but that's the way that I do it.
There's a ton of different ways. Well, the thing with Freeform is it's a very comprehensive tool set, so there's always like multiple ways to get the same thing done. You selected everything when you smoothed everything in the demo. You could have just selected the things you wanted to smooth, or you could have selected everything and then deselected the things you didn't want to smooth. There's the buck, there's masking, there's actually taking one piece, copying it to another piece. You can smooth one piece, and then the other one that which didn't get smoothed, you can chop the things out and just merge them together. That's one of the wonderful things with modeling with voxels, the ability to just munge things together and they all just blend and you just keep on working. You don't have to worry about topology and, oh, did this merge vertice or B-rep vertice edge align with that? Is there a gap? And then the model falls apart. It just doesn't work that way in Freeform. It's more about modeling as opposed to thinking how to model. You just get on and do what you got to do. Alrighty, got a question here. Currently has commercial licenses, educational licenses. If making more accessible for non-profit, we can talk about that. You know, we've got your information now, so we can certainly reach out and talk more about that.
And let me just talk on that real quick. So yes, there is a cost to Freeform, and I have a nonprofit as well. And so I think, yes, maybe you work with it, but there's also nonprofits that we have worked with that have fundraised to create the ability to do the license, and then they use it. So like just, and this is no representation on Octane. I know they love to help and such, but I just know from like a personal, unless you have skin in the game, if you get something for free, it's not going to get used the way that it's going to need to. So the people that we've worked with have fundraised, that are nonprofits have fundraised, have been crazy successful with Freeform. And so my encouragement is to not only buy Freeform, but also budget in training. And then, you know, yes, we can work with you on pricing, but you know, buy the software.
It's just got time for one or two more questions. There's a question here on, where is it? Doing the export. Sorry, I'm just looking for it. Dynabot, does Dynabot come? It comes as standard with Freeform Plus at the moment. And then in the next version, we're going to enable the running of Dynabots in Freeform. There's two different versions of Freeform. There's Freeform and then Freeform Plus. So like I was saying, in the next version, we're going to add the running of Dynabots in Freeform, but you'll still need Freeform Plus to write those Dynabots. And then the other thing we're looking to add in the future is the ability to encrypt and lock Dynabots. So what we're finding with our customers is that as they're writing more and more extensive Dynabots, there's a lot of IP that's going into those, and they don't want to, you know, let that get out into the bigger world. So we're going to encrypt and then lock Dynabots to a particular workstation. And then the other thing that's allowing people to do is to then, as they develop their own IP, they can sell that to their own customers. But that's one thing we're looking at doing for the next version. So, and then I'm still looking for this question. Can anyone see the question on exporting, converting from meshes to?
I do have a question too, Kevin, and you know, I know you guys make the rules and stuff. I've got time where we can go through all these, and I know people can hop off if they want to, but this is a lot of questions, and there's some really great ones, and we can try to answer them. But I don't know how you feel about that. It probably breaks the rules, but I'm definitely.
I don't think it breaks the rules at all.
Okay. So.
Yeah. I don't think this is just an hour. I don't think we're going to get kicked off after an hour. It's just a matter of respecting everyone's time. But yeah, we can go through these and answer these if you have the time.
Yeah, I would say for those that, you know, want to stay on.
If you don't have time to stay on and your question's on there, you can leave and then check back on the recording.
Yep, indeed.
So
I
mean, I'm good with starting at the beginning. Yeah.
will this session be recorded and shared? Katie already answered that, but yes, it is recorded. And then once we finish this, you will receive an email and you'll have the link to the recording. And then the next one is for Brent on Mesh Mixer.
Yeah, so it says, Brent, were you also involved in the 100% Mesh Mixer prosthetic workflow design process that can be found in the Mesh Mixer YouTube? So I was definitely an early adopter. I was not the first, like there's never like, but there were, I think that I helped add to the body of knowledge of the Mesh Mixer workflow. So it depends on where you found it, but there were a bunch of people early on. So you had Jeff Aaronstone, Derek Schmidt, trying to think of who else was there early on in 2014, 15, that sort of thing. But those are the people that come to mind that have really put out some great content on the Mesh Mixer. The gradient buildup tool was cool. Agreed. Says other CAD and design suits have student or demo versions for training. Does Freeform have this option, knowing that you need a haptic pen to take full advantage? So great question. So you can do stuff with a mouse, but it does hamper your ability to do a lot of things. So I know some people that have done Freeform with a mouse. They didn't, and they knew, or they had a haptic device. This is the funny part. They had a haptic device, never plugged it in, only used a mouse. And I said, you should use the haptic device. It opens up a whole new world. He goes, no, I'm good. I've got a mouse. And I go, I'm serious, man. Try the haptic device. And he tried it, and he texted me. He's like, okay, this just opened up a whole new world. So the haptic devices, the one that I like that has the buttons on it, there are two. One is the expensive one. That's the way I know it, at least. But it's very cool. But I actually prefer, and I've used that one, but I actually prefer the lesser one because it has buttons on the actual haptic device itself, 2 buttons instead of just 1. And so for me, it's just faster that way. So Octane works with educational institutes, and they have phenomenal pricing. So if you're an educator and you're interested in this, it's a great option. We can go through that with you, but it's not free, but it's not crazy. So
and just letting you know there, the haptics team have now put 2 buttons on the expensive haptic as well.
Well, there you go. So now it's just going to be the expensive device. It's just going to be the expensive haptic. So, but I think that's a good point. So they're just like any other device. That haptic device has a higher resolution. So if I'm doing facial reconstruction and I need pixel control, this would probably not be the right device. And we're not talking about that for the prosthetic and orthotic field. Plus, most clinicians, business owners, are cost conscious. And so I would just say it's for prosthetics and orthotics, you do not need the expensive one. If you want to get the expensive one because you say you have it, then that's a whole different thing. But the less expensive one, cost effective one, works just fine. So
yep.
All right.
The lattice question, we'll answer that one separately from Vivek. Thank you, Vivek.
Yeah. So there are going to be better options in 2025 for some of that, and we're talking about like 3D lattice, so not just rib style lattice. So I think yeah, beautifully designed. I'm sure that was aimed towards Katie's prosthesis and Dynabot, and I would 100% agree. That's amazing. What skill set is required for a new user to implement automation? Katie, you want to take that one?
Can't hear you, Katie. You might be muted. You might be muted.
What skill set is not willing to quit? I mean, I didn't know how to do any of it, and there's a little PDF that kind of briefly describes it, so reading that and doing it. But I think there's another question down in here somewhere talking about would do you offer consulting services or teaching Dynabots to a team to help them set up for their current workflow? So I think the answer is always probably yes. We could help with that. On what level? You just gotta not be willing to quit, and then you'll figure it out. Or Kevin, you take it.
Yeah, we offer training courses, beginning to advanced training courses on the use of Freeform as well as Dynabots. All our customers, get different very quickly, so you get into custom workflows pretty quickly, and that's where the difference between advanced training and basic training. But we have experts. When you buy the solution, you get full support. You can ring us up. We're always happy to talk to customers, talk to them about their problems and help figure out the problems. It's all about figuring out the customer's problems and making sure they go happy at the end of the day and getting things done faster and easier and better, etc. So
and I would also
go ahead. Sorry, Brent.
I would also say on that is you have to know what the inputs are and the outputs are. Like, you can't just go straight to a Dynabot. Or you will literally be burning, lighting money and time and stuff on fire. So it does take a few instances, like, the BK socket, it is beautiful Dynabot, that sort of thing, but it represents like 6 years worth of, pain and anguish of, through the Mesh Mixer Fusion 360 workflow, trying to figure out what tools work in Freeform. And so those are, it's important that you know those two before you dive into the Dynabot. So I think the Dynabot's kind of like the cherry on the top, but you do have to know how to do some of this stuff, or be taught how to do some of this stuff before you jump into the Dynabot side of things, so you know what's coming. And we've done this where we've created a Dynabot and it works amazing on one product, but we have to change something just a little bit and then it doesn't work. And so it's like, how do you get the best of both worlds? And then how do you create these building blocks or chunks where you can merge some of your Dynabots together to get what you want?
And that's an important point. You say, you have a Dynabot for one workflow, one design, and you take it to another and it doesn't work. It's not that generally, it's not that the whole Dynabot falls apart. It's generally that some part will fall apart. And that's the nice thing with Freeform. You automate as much as you can, and then when things fall apart, you still have that comprehensive tool set behind that you can pick it up and get your job done, so you're never stuck.
Exactly. So for instance, that happened to me, right? I had this like beautifully Dynabotted thing with a specific lock on it, and it got like midway through, but I had realized like, hey, I'm going to change the trim line a little bit, and it just didn't work with the selection method. So I just stopped the Dynabot and did the rest manual, and I wasn't stuck. So
right.
I think that's an excellent point, is that you're going, as long as you know how to use the software, you're not going to get yourself into a situation that you can't get out of.
Yep. How did you automatically align the standard part with the scan data? I think that's for Katie.
I can hit that too.
Sure.
So we make some assumptions already, like in the CAD program. So we build off of the origin, and so all of our parts that are defined parts come in on the origin. And so I think that's really important. And then we move all of our pieces to the origin. So that is our foundation. And then all the organic stuff gets built on top of that, so we can make the automation work. And so when you do your designing, we like to make sure that you're building it symmetrically off the center part of the origin. Now, Kevin, you can speak to this. The coordinate system of Freeform is different. So sometimes we'll have to build in our CAD software according to or flips things in Freeform. But we've gotten to the point where we know the coordinates of Freeform because that's the input that we need. So we just build it that way in our CAD software.
Yeah, and it's not that we're necessarily different in freeform, because global is global, and we respect the same global system that's in the CAD system as in freeform, and all general design systems. It's generally what we call Y up or Z up. A lot of mechanical CAD packages for some reason have Y as their vertical when you hit a standard front view, and then I think it's automotive, they tend to go to more Z up, but it's just something that changes between different CAD systems. And then in freeform, we can change it in settings. So when you hit the default front view, F2, it goes either Y up or Z up.
And I think that's the beauty of it, is you can make it how you want to. There's plenty of settings options to set it up the way that you want to.
Yeah.
And that's the thing is, I mean, I would say even though I've been in it, there's so much to learn to make you better and to be more efficient. There's, at first you start gaining hours into your efficiency, and then you start knocking off, say, 15 minutes. But now we're getting to the point where we're kind of hopping in the weeds and being like, okay, is it Y up or Z up? Well, now you're saving a minute, instead of flipping things around. If you actually flip it in your original settings, then you're done. So I think those are things that are important for people to know, is that you can set it up the way that you want it to.
Yep. There's a question here on, is it possible to get a Dynabot file as an example? When you load the software, if you go to the load point, there's actually a whole ton of Dynabots in there as like example Dynabots. So you can go through those and you can start to see how they're written and learn how they're written. And then also there is a reference guide in the load point for the software as well. So you've got that complete comprehensive user guide. It's not like a full user guide, but it's more of a reference guide on how to write Dynabots and all the different functions of Dynabots. So that's already in there. Training. Can you let us know how we can get the necessary training to make our digital workflow journey successful? There's not a ton on YouTube as compared to other solutions.
I mean, so you're absolutely right that there's not a lot on YouTube, and I think it goes back to your point is the people that use freeform, the industries are so diverse that while some of the tools maybe are used, the workflows are different. And so, we're going to try to put out as much information out there. But what I would suggest, if this is truly something that you're interested in, and what most of the customers that buy from Advanced 3D as a reseller, is we provide some basic training. But then also most people will add like a 2-day package of training, so we can dive straight into your stuff. And what we do is we actually break those 2 days of training into 2-hour segments. So, and those are recorded. So then you create your own tailored library of trainings for what the stuff that you're working on and important in helping you problem solve. Kevin, I wanted to touch on this. We touched on it a little bit.
Sure.
We had if there is a Boolean operation to be performed, do we need to convert to clay into solid mesh, then perform? Okay, so it probably wasn't the best example for me to do it the way that I did it. It's the way that I do it, and so I used to not do it that way with the mesh, but the emboss tool now will poke through thin surfaces. And so that's what got me into that habit. But to answer the question, is the best practice is to do most of your Boolean operations in the voxel space or in the clay, and then your final Boolean operations that have the detail will be actually done to the mesh itself. Is that a fair statement?
Yeah. And when you were saying about the offset, it used to break through the clay. That was something we had a lot of complaints about from the customers years ago, and we've actually improved that now. So you shouldn't see it breaking through thin pieces anymore.
Yeah, so like 2024, that's why I started doing it that way. Before, I would actually thicken the mesh and Boolean it back together onto the clay, poke through, and then cut it away. So this just takes a step away. And so not having the context of that probably wasn't the right thing. Maybe you can use some AI to fix my wrist hand orthosis the way that I did it.
The other thing with mesh as well is there are certain things that are definitely better off in mesh, like when you're putting in text, for example. If you want, really crisp text, especially if it's really small, then quite often with clay, you have to up the resolution, and then the whole model starts to slow down. But if you just convert it to mesh and then put the text in mesh, it's super sharp, it's sharp edges, you don't get into any sorts of resolution issues. So mesh labels, text, that's always a good thing to put in right at the end when you're in that last mesh mode.
Okay, so you got some fan mail there. So it looks like you'll have something to respond to. So that's good.
Yep. And if there are any questions we don't answer here, we will write out on emails and get them answered as well.
There is some stuff about the main specs of the PC. I would say that most workstations are going to be able to run this. So yes, you can get a custom PC made. In fact, shout out to Chris Touchberry. If you're watching this late through the frequently asked questions, I'm sorry, but he has a great option to build custom computers specific for not only scanning, but for freeform, and does a beautiful job. So highly suggest that. They're going to be a little bit pricier, but you've got a custom specific setup for this. Now, for those of you that have a Costco in the area, here's a little tip for you. Costco has gaming computers by MSI that they sell on their online store, and typically they have an i9 processor with 32 to 64 gigs of RAM and a very nice video card, Intel video card. So my suggestion, so the stuff that we run, we find that it runs best on a good video card. And I think even the least expensive video cards are even better than what I run now. But I think that's like the NVIDIA 4070 is fantastic. If you go 64 gigs of RAM and i9 processor, you're going to be good to go to run everything that you need. It is critical though that I would say stay within the Intel architecture. We made the mistake, for the processor. We made the mistake because we thought we were going to get some speed to buy a really high-end AMD, and it is smoking fast, except for the things that we need it to be fast on, because they just the way that they do their architecture and I don't even know what I'm saying when I say CUDA cores, but I know that the AMD does not have that, and Intel does on the video cards, but they talk better to each other when it's Intel, NVIDIA than another way around. So that's the layman's perspective on computers.
We definitely do support AMD as well, both CPU and GPU, but we do see better results with Intel CPUs and NVIDIA GPUs.
Yeah, well, and so this is right. Well, and so where it hit us the hardest was actually on the scanning side of things. So we love ArtTech for the scanning side, and somebody asked about Hasco. It's a Costco, COSTCO.
It's a big box retailer here in the States.
Yeah. Shout out to Jan Nielsen. He's pretty amazing, and he's doing some really amazing things. He uses a lot of freeform. If you want to take that one, the upload images.
Yeah, you can, with Dynabot, you can basically link everything to an HTML window, and you can program that HTML window, using HTML, and then anything you can put into an HTML window, you can then put into that Dynabot window, including images, text. You can have pull downs. So, for example, if you put change from mesh into clay coarseness in that HTML window, you can have a pull down, then you can just pick the clay coarseness or an offset or anything, and that stops you just typing things in. So it's actually really powerful to link Dynabots with the HTML window. And if you want to get more into that, then give us a call. We can certainly start pointing you in the right direction.
So, okay, the consulting stuff, I think we covered that. Why is it
Yeah.
required to convert into a mesh in the last step from clay? So it's not required to convert into a mesh. Depending on what your clay coarseness is or your resolution is, you may end up with a large resolution file that becomes difficult for your slicer or say your powder bed fusion file management system to handle, especially if you're slicing on the machine itself. You may end up, unintentionally increasing your build time because your files are so big and they don't need to be. So I would say this is more of an advanced thing, and for most people, it's not going to make a massive difference, but for those that are actually waiting for files to transfer onto their printer and slice on their printer, they will love you when these files are much smaller. So what I've found, if I can keep them under 20 megs, I don't lose any resolution unless I'm doing lattice structures, 3D lattice structures. I don't get the pixelation. So if I can stay under 20 megs, I keep the technician that runs the printers happy. I keep my slicer happy if I'm doing FDM, and everything's well. So that step to go into mesh, I would say, is an advanced step, and it's thinking downstream. Like, more than likely, whoever's receiving your file is going to reduce it so they don't have the pain as well. So I just like to have full control of my file to make sure when it's reduced that I don't lose some of those features. And
there is
that's in the weeds.
Direct,
yeah.
Oh, sorry, Brent. There is a direct export to mesh from clay file, and you can reduce as you're going through that. And that's a pretty intelligent command because it will keep the detail as you're reducing. So you don't have to go like clay to mesh to then reduce to then export. You can go straight from clay to reduce to export. It's various things. Each different way has, like Brent was saying, you're getting into the weeds of one thing works well in one place and not the other. But 9 times out of 10, you can just use some of the major commands and just get it all done. Always different ways to do lots of different things. Alrighty.
We're getting close to the end, folks, but people are still hanging with us, so this is kind of cool.
We appreciate it.
Injection molding workflow. Yeah, that's not me. There are some super cool tools in the molding stuff, but I don't know anything about that, so you'd have to get up with Kevin.
Yeah, there are some molding tools in Freeform, and if you do have questions there on how to use those tools, again, we can take it offline and figure that out later. It's a way bigger conversation than this Q&A session.
Yeah, a majorly X rotation by 90. Okay. Topology optimization, finite element analysis program. Do you use? So you can't do that in Freeform, at least that I know of.
Nope.
So what I will say, kind of to Kevin's part, your mileage may vary, which also means this is not a medical, all those things that he said at the very beginning for his people. What I would suggest is really to dive into what part needs to be strong. You do an FEA on those particular parts, and then be consistent using those parts when you're making your prostheses. So for us, what we have done the analysis on are the distal ends and how it actually connects. So for instance, when Katie was saying that we loft in more of a flat surface rather than a reverse curve, that is because the strength was so much better when you have a loft versus the reverse curve. And so we now have made that a standard practice in the way that we make our sockets. Now, we're also looking into how do you lightweight that? How do we, there's more steps to go, but my encouragement is you do the analysis on your model, and then you also do a physical analysis to make sure those talk to each other well, and then be consistent on making your prostheses in those specific ways. Is that a fair assessment?
Yep, definitely. And we do have some a lot of customers who export to things like ANSYS and everything like that. But that's not something we particularly get into. We just do the STL export, or we can auto surface and then take those surfaces out. But then the actual FEA side to it, we're really hands off.
Okay. Somebody said something, bend and twist is faster in mesh. It is, but sometimes depending on the resolution of your mesh, it could be a disaster. So, but that's good to know that. And I think it's important to know that there are tools that allow you to be used in mesh and clay, and those are kind of like the little fun Easter eggs to find, like, hey, which ones actually work better. So I think that's a great observation.
That's from Mike Silver. Big shout out to Mike Silver. He's been using Freeform for a long time, and he's a great guy. Used to be part of the HSG team here and has moved on, unfortunately.
Yeah. Great to see you, Kevin. Katie said, good job. Can I use a PDF file to start a sketch? I don't see why not. Probably it depends on what it would be for, but I would say most of the time you're going to want to do that in your parametric software if you're actually wanting to create something from there. So you're still sharing, Kevin, so I don't know if you...
Yeah, my IT guys are just telling me to redo my... It'll work out.
So, but you can use, well, I don't know, can you do a PDF file or does it have to be a picture?
We can import into Sketch like all the image formats, so JPEG, BMP, etc. And then we can import AI, we can import DXF, and I'm pretty sure we can import IGES. I think we'd have to double check that one. But for PDF, if you have like explicit curves in PDF to get them in, I'd have to double check that.
Okay, cool. But there's a lot of great ways to use images as references in Freeform, and so I think that's a great thing to do, and more people should do that. Katie answered, do you still use Fusion or any other parametrical software in your OMP process or just Freeform? So yes, we use a lot of Fusion 360. But I will give a shout out. It's been a long time since I've used DesignX, but DesignX has gone to a subscription model, so it's much more affordable. So if you're looking to reverse engineer, it's a super powerful program to do that, and I would highly suggest taking that out if you want to dive into the weeds. You talk about weeds, that's a great place to jump in. But I will tell you this, I forget the guy's name that trained me. Was there Mike that trained or was training Freeform or DesignX in Cary?
Yeah.
His name Mike? Is he? Is the best training I ever had. So I've been to a lot of trainings on software stuff, and it was amazing. Just the thought process, whether he's still training or not, the idea of how he trained and how the DesignX was used, it was amazing. That's the one. Yep.
Great trainer.
Best training I ever had on software. So highly suggest, and that is an extra charge or fee, but if you're going to get DesignX and you want to get the most out of it, I would big shout out to those people that are training in that.
Alrighty, I think
that's the end. So we're only 30 minutes past.
Mike Silver's just put in another question for auto surfacing. Oh, neat. Just saying he uses the auto surfacing all the time and exports from IGES into SolidWorks. Yeah, we work. Freeform will work with other pieces of design software very well. What Freeform does, it does very, very well. But if you're doing mechanical components, can you do them in Freeform? Yeah, but you can do them so much better in your regular CAD system. So STL, OBJ, PLY, IGES, Parasolid, binary and text, step, we export and import all those. So we're happy to work with, with other CAD systems as well in the entire workflow.
And I think that's a good point too, is, Katie and I have used the auto surfacing on like a custom component, but we want to potentially make it parametric. And so you may have something that you really like in the organic space, you auto surface it, and then essentially reverse engineer it in the parametric space, because you can export as a step file and grab curves and cross sections and all that stuff. So it is a very, very powerful tool in Freeform. So I think is that in Freeform and Freeform Plus? The auto
surfacing Freeform Plus, yeah.
Okay.
I think it might be in Freeform as well. I should double check that. Definitely in Plus. But all the solids tools, because you can make solids like regular CAD solids, that's definitely Freeform Plus.
Okay. And so I don't want to get into the weeds on the Freeform Plus, and I suggest, this is the beauty of working with the team at Freeform. You start with Freeform, you get better and better, and it's not that you're going to hit a ceiling. People have been very successful just in Freeform, but there are some things in Freeform Plus that as you get better in Freeform, you may want to bring in assemblies like step files and that sort of thing into your Freeform space, that you into Freeform, which would require Freeform Plus. But I would say, unless you just have money burning a hole in your pocket, start with Freeform, and then when you need those assemblies and some other tools that come along with Freeform Plus, like the Dynabot and that sort of thing, then you make the jump to Freeform Plus, and all you do, there's no penalty to do that. You just literally pay the difference of Freeform Plus and Freeform, and now you're in Freeform Plus. But I think it's important to do the tools in Freeform first, learn the flow. It's not going to hold you back, and then you will just love Freeform Plus that much more. But the reality is most people are not going to use Freeform Plus tools right out of the box. It just takes time in the saddle. It takes experience. So I know the sales guys probably won't love me for that, but I think that's where our goal is Freeform Plus. But you can start with Freeform, and especially Freeform now will run Dynabots. So even though you may not be able to create a Dynabot in Freeform, you could run a Dynabot of somebody's that you like, or of something. So you don't have to have Plus to do it.
Yep. Alrighty, I think we're at the end of the questions.
Yep. Awesome. Well, I think this was good.
Yeah, we ran over, but I think it was worth it to answer all the questions and get them out of the way. And if there's a couple here we haven't answered because they're very in the weedsy, so that we'll just email those to people. So we'll close it out. So want to say huge thank you to everyone who's logged on. Huge thank you to Brent and Katie. We really appreciate your help and your time here. And of course, if there's any more questions, if you think of anything more you want to ask, you can reach out. We've got octon.com/freeform, and there's a link on there. And then for Brent and Katie, there's a adv3dinc.com. So you can go to either of those websites, and there's places there where you can post more questions, talk to local people, etc. Okay, anything else?
I think that's it.
Grand. Well, thanks everyone again. We will close this one down. The recording will close, and you'll get a copy emailed to you of the recording. But thanks a lot for everything. Have a great day.
Thanks, Kevin.